welcome to our presentation. My name is Sigrid Schäfer-Wenzel and I'm here with my colleague Igor Miladinovic. We are both from Vienna in Austria, and we are going to present you our approach for integrating research activities into our computer science curricula. I will start with a short introduction to get you familiar with the topic, and then show you the goals and actions we did that led to our approach. Igor will then present you our approach where we integrated certain research elements into our curricula. So we are both from the computer science department at our university. We are teaching in the area of software engineering primarily. We have bachelor and master degrees in the area of computer science, and we are confronted with the reality that computer science is a rapid so there is a lot of rapid development in this area. There are constantly new technologies, and we have to educate our students to be able to work in this area, where they need to be able to learn new technologies fast. So we have a lot of research projects that also deal with these innovative technologies, and we wanted to integrate students into these research activities. So we wanted to enable students to work with us on these research projects that deal with some of these new technologies that they need to be able to apply in their future work. And we gradually increased the level of skills, research skills they need to work in these research projects. So we defined several research elements that we integrated into our curricula, and they increase in the level research skill level students require. We have mandatory and optional parts in our curricula where students can or have to participate in our research projects. And as I mentioned, the required skill level gradually increases with the study. So the primary goal of our studies is to educate students so that they are able to work in the software industry. And the software industry is an industry where we have new technologies very often. So one of the sub-goals to achieve this primary goal is that we want to engage students in research activities. That has several benefits. We also laid them out in our paper, such as, for example, they get familiar with new technologies, they train their critical thinking, they work in teams, and we can also reward talented students by participating in research activities. So there are several benefits, and in order to reach this goal that we can engage students in research activities, we have drawn this goal tree that shows the sub-goal of engaging students in research activities. On the second level, we see several critical success factors that help us to achieve this goal. And on the lower level, we see actions that we have taken to be able to achieve the critical success factors and then this goal. So the critical success factors that we need to achieve in order to achieve our goal are that we want to integrate research activities into our curricula. We will go into this critical success factor in 1 minute into detail. We also need to be able to provide attractive research topics, so students are motivated to work in this area. And we want to integrate students then into our research projects. And we have several actions so the actions are on this level that help us to achieve these critical success factors. For example, we have introduced dedicated lectures that really deal with enabling students to develop research skills. We also offer research-driven topics for election projects and final thesis in our curricula. We have integrated research elements into other courses. So we have integrated research elements into our technical courses so that they are able to apply these skills on technical subjects. We also have extracurricular research opportunities that are usually optional. We tried to increase the number of academic and industry partners in order to have more attractive research topics. And we also increased the number of research projects so that we can offer more topics and more elements. And now we go into the details. I will hand over to Igor.
Thank you, Sigrid. Okay, so this was our, let's say, it's called goal tree. It's according to Detmer theory for solving complex problems. And it's important, if we have a goal, we can formulate the goal, but we cannot achieve the goal immediately. It's not concrete enough. And the next level are here, as Sigrid said, they are critical success factors. They are more concrete, but still not actionable. And in the last level, we have a concrete action, for example, provide attractive research topic. I cannot, how should I do it? I don't know what action to take. But if I have increased number of academic and industry partners, then I will go to a company, I will go to other university, I will try to define a project. But it's why this order. And now I will talk about these concrete actions which we can do and how we implemented these actions with some examples in our degree program. So here these actions are once again, these 6 actions, and I will go action by action, and I will make a mapping to this pyramid. And the pyramid is according to the level of research skills. So basically, students from the first and second and third semester, they cannot do in the bachelor degree program, they cannot do a real research project. They still do not have necessary skills. There are some exceptions, but it's not. It is not on a regular basis. So we start with lowest level, which are courses. We defined some courses, we modified some courses. We have the privilege that we can completely define this degree program because we are responsible for this degree program. So we can change courses, we can introduce new courses. And this is the first level. The second level, it is or offering to the students, which is not included, mandatory included in the degree program, but the students can do it optionally to improve their research skills. Then the thesis, bachelor and master thesis, depending on the degree program, there's first bachelor, then master. And at the end, in the top of this pyramid, are the real research projects with our industry and academic partners. So the first step, first action, introduce dedicated lectures. We have 2 lectures we have introduced. The most important one is scientific technical writing, which is in the 3rd semester of our degree program, bachelor degree program. And we also have a presentation skills where the students learn how to present research results, research topic, and so on. These are 2 mandatory courses. And it's a technical studies and engineering study. And the students which are coming to us, they want to learn programming, they want to learn coding, they do not want to learn scientific writing or presentation, professional presentation is not so interesting. That's why we introduce these modules where we combine these professional skills with engineering skills. So they are a kind of interesting situation because industry tells us constantly that the professional skills like presentation skills, writing skills, teamwork are extremely important, and the students do not want to learn it. They're not really motivated. That's why we define the modules, two courses combined together. For example, professional presentations and web technologies, and they have to present a topic from web technologies. So they're not presenting their last holiday or something like that. They're presenting an engineering topic, and that's how we introduce these courses, and the feedback from students it's quite positive. It's more administration to organize such courses, but it works for students. So these are these modules. This is the way how we implemented the first point. The second point, integrate research elements into other courses. So we took some existing courses and we introduced research elements. For example, for mobile app development, they have to write a small paper. It's about 3-4 pages, but it has to the paper has to have a scientific character. Should be like a normal paper with all the elements. The only difference is the idea needs not to be completely novel. And we also have a simulation of a conference. This is a course which prepares students for bachelor thesis. And in this preparation from bachelor thesis, it's called bachelor thesis seminar. We are organizing a small conference where each student is presenting their work, their bachelor thesis, as like here, in 10 minutes to present a thesis and getting feedback from the others. So this is the way how we implemented or how we addressed this second action, integrate research elements into other courses. And now we have dedicated courses, we have research elements in other courses. The third action, research-driven topics for project and thesis. It is not in this picture, it cannot be mapped in this picture. But for this action, we have increased the number of partners, academic and industry partners, and defined new research topics which are interesting for the students, and the students can participate in these activities. Like on the previous presentation, the idea was, or the message was, tell me and I will forget, teach me and I will remember, involve me and I will learn. And this is how we, how do we involve students in research projects. Then extracurricular research opportunities. We have different possibilities here. We have a kind of not one. Currently, there are 3 hackathons where the students are working intensively on one specific topic. So they are closed in a room, not really closed, but they are completely days, usually on the weekend, 2 days working just on these topics. We are taking care about food, about drinks, about everything. They have to stay there and work on an idea. And the idea, or let's say the issue is coming from other disciplines. For example, we have a cooperation with University of Law in Vienna, and there are law problems which we are solving with the software, similar to text management. So that we have mixed teams, about 4 or 5 students, 2 from one university, two from other university, and they are working on the same on one concrete problem. At the end, there is a kind of announcement of the winner of this competition, and after this is very interesting how much they can achieve it in just a couple of days, but it needs to be full days. So these are the hackathons. They are optional for the students. They are not a part of curriculum. We have design thinking workshops with experts on this area. We have a company providing design thinking courses for other companies, and we have a cooperation with them that they also teach our students. And we have student-led projects. We have two forms of our study, of our degree program. The first one is just a standard, normal form. The second one is in the evening for students which have a daytime job. And they have the possibility to take a problem from their company and to solve it in a project with us. This is student-led projects. And the next action is increase the number of academic and industry partners. It is not an action which can be completed. We are continuously working on it and trying to find more and more cooperations. Some of the cooperations disappear. But there are always more new cooperations that the cooperations which do not work. And with this way, we also increase the number of research projects which we are offering to students. So with these research projects, we can address topics for bachelor thesis, master thesis, and the dedicated research projects where students are working for also outside the degree program, and they are paid for that. There are some students raised for these activities. It's called junior research, and they can work on these research projects. So we recently just completed two projects together with the University of Vienna, and one project was, for example, the connection between music and coding and software development. Like in music, we have defined tools, we have defined tones, frequencies, defined duration. If we combine these elements in the right way, it will be something nice. Similar to programming, we have dedicated commands, and if you use the commands in a good way, the software will be fine, otherwise not. And this was fully implemented by a student of us. So no other stuff involved in this project. So this is this pyramid. Let's say this is very optional for the students. There are about 15–20% of students which take this opportunity. This is, of course, for all students, but not all are working on a research topics. It's always more and more, and it's work in project. It's work in project, and we think that it's very important that the students, for the later career of the students, that they do some research by their own. And this is our last slide, concluding everything what Sigrid said, what I said, that opinion is that the research skills can help students to develop professional skills. So professional skills or soft skills like teamwork, like presentation skills, like writing skills. And we developed an approach to systematically integrate research elements into the degree program. Our experience is that the most students are better decision makers, are better influencers, can also present something more convincingly. Also, at the end of the degree program, they have to present their master thesis, bachelor thesis in a small audience. And we see that the students which are trained to present results are better in the presenting results. In our future work, as I said, it is work in progress. We will continue to evaluate the methods, how to integrate research skills, what should be integrated, what should not be integrated, and yeah, we will then present new results as far as we have them. Thank you.
How many faculty do you have in your department, computer science department?
How many?
How many faculty?
How many? How many faculties? We are organized a little bit different. We have degree programs. We do not have faculties, but it's comparable with degree programs, and we have 2 bachelor's and 2 master degree programs. Yeah. They're a little bit different focus, but basically they have in common that programming is extremely important. It's software development.
We are organized so that we have staff that is employed, so full-time employed, and staff that only holds lectures.
Yeah.
And full-time employed are about 15.
15, yes.
15 or so, yeah.
And about 40 external lectures.
Okay.
Yeah.
How long has this project been implemented, and do you have any data before and after in terms of outcome?
There are several actions, and there is no like a big bang. So now we implemented everything. We started with the implementation of all these elements 5 years ago, and continuously we introduce more elements, and yeah, this is now. I think yeah, the youngest elements are about 1 year, and the oldest about 5 years. And we do not have, let's say, it's difficult to compare before and after because they are also different students, they are different years. But we do see that industry is requesting our students more and more. So our graduates are more attractive for the industry. So we have they're finding a job within a couple of weeks. Yes.
What's kind of the strategic goal of the project?
What kind of strategic goal?
Yeah, what's the strategic goal, the long-term goal of the project?
Of
Getting students into research projects is like it's more like a passive goal.
Yeah, I see.
So what do you want to achieve with it?
Yeah. Our strategic goal, or let's say our long-term goal, is to have graduates which are on the top level of the knowledge, and which are desired by our industry partners. So to have graduates which are ready to contribute to the industry and also research.
It's not that much about participating in research, but getting in touch with content.
Yeah, it is just let's say this is not the goal. It is just the way to reach our goal. It's not just we want it because it's yeah.
It's not about making them practitioner researchers.
Yeah, it's not about them.
Getting content.
Exactly. Do you want to add something?
Well, going back to that one thing that it's rapidly changing technology. So you can't be, you got to get them into the mindset that they have to continually be feeding themselves and learning on their own too. Because
yeah, it's an important skill. It's an important skill for computer scientists to be able to get familiar with new topics fast. And one goal also was to be attractive for talented students. And we think that talented students are also want to develop their research skills, and they are motivated by this. So there are several factors that come together.
we always say they have to learn how to learn
Yeah.
during the study. It's impossible to get because the tools from today are in 2 years they are old-fashioned. Yes.
Just curious, so with the research elements added, do you find that more students are pursuing like further advanced degrees in research? Is
Mhm.
that
Yeah, we have seen a big increase in the number of applicants into our degree program. We have done several changes, and this is one of the changes. And before that, we had nearly no students that worked in research projects, and we also had only a very limited number of research projects. So this is definitely one point that has made us more attractive for students. And yeah, numbers have risen constantly.
About three times more than 5 years ago.
Great, thank you, Susan, thank you, Igor.
Thank you.